So since you now know what the Coriolis force is, you can think about the scenario. What happens if you have a storm, a sudden big storm in the ocean that pushes water into a certain direction, and then the storm disappears and you have a motion only influenced by the Coriolis force. And these type of motions in the ocean, we call them inertial oscillations. They are horizontal flows exclusively driven by the Coriolis force. And here's one example. And one example where you actually trace this motion through we call it the trajectory, the pathway of a particle. Okay, so I want to show you this movie, if I can start it. Let's see the movie. It's a particle. And you can see these circular motions. Okay, you can see it's sort of clockwise. Okay, and in addition to that, you can see a general path to the northwest. Okay. There are two things that you can see here. One are inertial oscillations, and without any other currents, actually the inertial oscillations would move a particle just along a circle. In addition to that, you can see an underlying ambient flow which moves the particle on the spiral type, towards the northwest in this example. And in the ocean, if you measure in the open ocean, in the surface layer, in the surface mix layer, you usually observe inertial oscillations. Okay, that's something that you should be aware of if you do measurements in the surface mix layer in the open ocean. It's a very, very prominent feature that you find in the oceans.